In this example, we have graphed a set of parametric equations by making a table of values. We have x is defined as equaling 2 times cosine of t, and y is defined as equaling sine of t. T is going to be our parametric variable. It will define what is happening as we progress through time. That's how you can think about t. Furthermore, we also have a restriction on t. T is said to be between 0 and 3 pi over 4. That is going to be pretty helpful, particularly when we try to go through this by creating a table of values, as we do have restrictions for what kind of values we can use for t. I will create, in this case, a literal t table, where I will be plugging in values between 0 and 3 pi over 4, and I will get x and y in return, and I can graph from there. The values for t that I will use, well, the lowest number I can use is 0, so let's go ahead and use that. The highest is 3 pi over 4, so I should probably do at least values that iterate through pi fourths. So 0, pi fourths, pi halves, and 3 pi over fourths. Hopefully that will be sufficient, but if not, keep in mind that you can always plug in more values to test. Just keep in mind where that would be in your timeline here. For example, if I choose to also do pi over 6, well, pi over 6 is between 0 and pi over 4. So whatever x and y coordinate I get from that would have to take place between what I currently have as my first and second point. So think about this as a timeline. But let's just plot these points here. If I plug in 0 into these functions, I will get, first for x, 2 times cosine of 0. Cosine of 0 is 1, so that will give me just 2 from this. Whereas if I plug in 0 into t for the second equation there, sine of 0 is 0. Next, pi over 4. 2 cosine of pi over 4. Well, cosine of pi over 4 is square root of 2 over 2. And that is also going to be multiplied by another 2, meaning I just get the square root of 2. Or, if I approximate to a decimal, since I will be plotting this onto a plane that doesn't have roots on them, that has decimals, I'll round square root of 2 to about 1.41. Whereas if I plug in pi over 4 into sine of t, sine of pi over 4 is square root of 2 over 2 again, but this is not going to be multiplied by 2. So this is just the square root of 2 divided by 2, which is roughly about 0.71, approximately. I can continue by plugging in pi halves now in for t. If I plug in pi halves for cosine, cosine of pi halves is 0, and 2 times 0 is still 0. Whereas if I plug in pi over 2 in for t for the second equation, sine of pi over 2 is 1. And lastly, if I plug in 3 pi over 4, well, I'm just going to get the same values I did up here when I plugged in pi over 4. However, one of those is going to be negative. When you plug 3 pi over 4 in for cosine, cosine is negative in that quadrant 2. So I'm going to get negative 1.41 approximately, and another positive 0.71. You can keep all answers exact here, but I'm just rounding so that I can graph this a little bit more appropriately on my curve here. So let us start graphing. The first point that I want to plot here is 2, 0. So that'll be over here. That is point 1. I'm going to label it just so you know what is the first point in the sequence, and then so on and so forth. The second point I have is about 1.41 and 0.7, which puts us around maybe here. That is my second point. My third point that I have is pi over 2 from t, and that is 0 and 1. So that's my third point there. And then my fourth point is from 3 pi over 4. That gives me negative 1.41 and positive 0.7. About the same height, but on the other side of the y-axis here as the second point. And that's it. Based on our restrictions for t, there is nothing further to go beyond this. It will start at this point at 1 and will end at this point at 4. So we're not going to have a full curve or anything. It's just going to start at a point and end at a point. If I do connect the dots accordingly, I will get a curve that looks kind of like this. Now, in order to make sure that this is correct, I also need to include the orientation of this parametric curve. Always include the orientation. And to do that, just indicate arrows along your line from your first point onto your last point. So for my first point, I'm traveling to the left along this. That would indicate the orientation of this curve. And that's the entire thing. If I were to continue this, if t actually were infinite, then what this actually would look like is an ellipse. However, because we are only taking a portion of this, we are basically just defining a slice. So we have the entire curve here.